Well, we're doing mechanical waves. That's a wave with the medium, like arm waves and water waves, sound waves, stuff like that.
And waves?
No.
Okay.
You ready?
Yeah.
Okay, electromagnetic waves are waves that don't need a medium, like microwaves, light waves, and X-rays.
How about sound waves?
Not sound waves, Joel. Not sound waves. There it is. Okay. Transverse wave, the particles in the medium vibrate perpendicular to the direction of motion. La la la. Do I do the second one? Oh, I don't know what the second one is. A longitudinal wave is particles of the medium vibrate parallel to the direction of motion.
I'm trying to talk about the real.
A surface wave is a combination of a transverse wave and a longitudinal wave.
We're measuring waves, and there's frequency, the number of complete vibrations per second measured at a fixed location. Units are hertz. Ready, Joel?
Ready.
Go. 1 Mississippi.
That's good.
Yeah, that's a good one.
Alright, so,
Alright, now amplitude.
well, that's frequency. So frequency is how many times it goes up and down in a second.
Yeah.
So that was 1 second. So this would be like 1.5 or something like that. Right?
Right.
There you go.
Amplitude, the maximum distance from the rest or equilibrium position.
Equilibrium would be the top, so that's the distance. This amplitude, this is also amplitude. Double amplitude.
That's right. Next is the period, the shortest time interval during which a point has its motion repeated. Standard units are seconds.
Period.
Alright. Velocity is the distance or the wavelength over the time. It's also how fast it goes.
Basically how fast it's going that way. Like the arrow says.
And then there's wavelength, which is represented by lambda, and is also the distance of the entire wave.
So from here to there. Bam!
Lambda.
Oh, lambda?
Yeah, it's represented by lambda. Draw the lambda.
Draw lambda.
Wait, I'm not good at drawing lambdas.
I'll do it.
Alright, Larry's coming to draw the lambda because I'm not good at drawing lambda.
That's a lambda.
It's a beautiful
It's a
one.
lambda.
Alright, constructive is when they're going in the same direction and it results in a larger amplitude. As when Larry went up, they came together and went up and went back down. And they kept on going in their same direction. Destructive is what Joel did, as they're going in opposite directions, and when they meet, it becomes amplitude of 0, and then they keep going.
Is that an example of?
Destructive interference.
Go.
We're filming. Alright, Doppler Shift. Basically, when we were running past the camera, you couldn't hear it too well with us because we weren't moving fast enough. But when objects move past each other and they're making like a steady sound, like a steady pitch, sometimes, like if it's going fast enough, it'll sound like the pitch is changing because the waves build up on each other, and it's called the Doppler Shift.
With Allison, me, Joel, Larry.
When Wes was singing, he had a very high pitch, and that comes from frequency, right?
It is frequency.
And amplitude is what determines how loud it is, which he was pretty loud too.
Them? First? What?
Beat.
Oh.
Beat, please.
Yeah.
Speed of light, test 1. That was fast.
Okay. Rainbow. Hence, it says rainbow up there. Anyways, the colors are red, orange, yellow, green, blue, indigo, and violet. Basically, every time there's a rainbow, there's a reflection of it underneath, which is the opposite. So you see biv, and I'm not going to try and read it backwards because I'm dyslexic. But anyways, yeah, like what? Anyways, that's how there's a double rainbow, and we all know it's intense and amazing when there's a double rainbow. So, okay, when two waves of the same, actually I don't.